Hello everyone, welcome to a personalized episode of Enlighten Me. Today we delve into the integration of third-party GPTs into ChatGPT, explore the health tracking capabilities of the Oura Ring, and discuss the transformative shift from RNNs to transformers in NLP. Join us as we navigate the latest developments in AI and digital health. OpenAI enhances ChatGPT for paid users by integrating third-party GPTs directly into conversations. Users can now tag these GPTs, which are aware of the chat's context, by typing it followed by their selection. This update follows the recent GPT Store launch, a marketplace for GPTs that doesn't require coding skills to build, ranging from simple to complex applications. Examples include a trail recommender, a code tutor, and a content designer from various organizations. OpenAI plans to allow developers to monetize their GPTs, despite current challenges like moderation and low custom GPT traffic, which is only 2.7% of ChatGPT's web traffic and decreasing monthly. Early issues included the appearance of inappropriate romantic and political campaigning bots, which OpenAI is addressing through human and automated review systems. An open-source LLM dubbed Meek170B surfaced on Hugging Face, resembling the work of Mistral, a Paris-based AI company known for Mistral 8x7b. The model, similar to Meta's Llama 2, was also shared on 4chan, sparking interest for its high performance. Speculation arose that Meek could be a quantized Mistral model, leaked or released surreptitiously. Confirming, Mistral's CEO, Arthur Mensch, acknowledged an early access customer's employee leaked an old quantized model. Mistral has since progressed, hinting at a model rivaling OpenAI's GPT-4. This development could be significant for open-source AI, challenging OpenAI's dominance in LLMs as the open-source community rapidly advances. Google has announced a new paid Bard Advanced subscription, leveraging its Gemini Ultra AI model, a part of the multimodal Gemini architecture designed for complex tasks. This premium version will enhance Bard's abilities in understanding, summarizing, reasoning, coding, and planning across over 40 languages globally. Alphabet's CEO, Sundar Pichai, indicated Bard Advanced would be available this year, following a phase with early testers. Alphabet's Q4 earnings show a substantial $15 billion annual revenue from subscriptions, with plans to increase this figure through Bard Advanced. Pricing and release details remain undisclosed, but it could be in line with competitors like ChatGPT Plus, which costs $20 monthly. Currently, Google Bard is free, contrasting ChatGPT's premium tier. Apple is actively enhancing its artificial intelligence capabilities for the anticipated iOS 18 release, as evidenced by code from iOS 17.4 beta by 9 to 5 Mac. The tech giant is developing a new Siri version utilizing large language model technology, with OpenAI's ChatGPT API being employed for internal testing purposes. A new Siri summarization framework in iOS 17.4 suggests a focus on summarization and potential AI integration within the Messages app for tasks like fielding questions or auto-completing sentences. Although using OpenAI for testing, Apple is likely to rely on its own AI models for iOS 18, with internal models like Ajax being benchmarked against ChatGPT and Flan T5. The company's commitment to integrating large language models into iOS is clear, with Apple's software team under Craig Federighi aiming to infuse iOS 18 with AI-driven features. Now, exploring the impact of AI in modern browsers, Opera is set to introduce Opera One, an AI-powered browser for iOS in Europe, capitalizing on Apple's compliance with the European Digital Markets Act. This act mandates Apple to permit alternative browser engines on iOS, breaking Safari's WebKit engine monopoly. Opera, a Norway-based browser developer, welcomes the move, foreseeing increased competition and user choice on iOS. Jorgen Arnesen, EVP Mobile at Opera, highlighted the significance of the DMA and Opera's intention to utilize the opportunity to enhance user experience with Opera One's AI features. Apple's new interoperability request form is also anticipated with enthusiasm by Opera, as it allows for further integration with iPhone and iOS features. While the browser's launch aligns with the DMA's enactment in March, Opera urges Apple to extend these freedoms globally. Additional details remain sparse, but Opera plans a significant AI infrastructure investment in Europe and aims to align the new browser with its desktop counterpart, emphasizing readiness for an AI-driven future. With tech giants enhancing AI integration, let's now turn our attention to the Oura Ring's innovative health tracking capabilities and its impact on early disease detection. The Oura Ring, retailing at $299, is making waves as a health monitoring device that tracks sleep, heart rate, temperature, and respiratory rate. This Finnish startup, founded in 2013, initially targeted sleep quality improvement, but has since gained attention for its potential in early COVID-19 detection. Oura's product is a sleek titanium ring equipped with advanced sensors, offering a daily readiness score through its app, advising users on physical exertion levels based on their health data. Valuable for its unique form factor and comprehensive health tracking, the Oura Ring has drawn interest from high-profile individuals and organizations. The NBA and the Venetian and Palazzo casinos have adopted the ring to monitor the health of employees and players. Oura has also partnered with researchers like UCSF for the Tempretic Study and the Rockefeller Neuroscience Institute to explore early symptom detection and AI-driven health forecasts, showing promise with a 90% accuracy rate in symptom prediction. Amidst the pandemic, wearables have become crucial for health monitoring, and Oura's enterprise management platform now allows companies to track employees' health data. Despite the challenge of differentiating COVID-19 from other illnesses, the ring's data is being used to potentially alert users of infection before symptoms appear. Tailwind is revolutionizing the marketing landscape for small businesses by tackling the inefficiencies of current marketing technologies that fail to serve the unique needs of these enterprises. Recognizing that small businesses are pivotal in driving job creation, innovation, and economic growth, Tailwind aims to level the playing field, enabling them to market with the prowess of their larger counterparts. Founded by Alex and Danny, who initially devised marketing tools for their own online business's needs, Tailwind quickly became a leader in Pinterest and Instagram marketing. With a growth spurt to 35,000 paying members by the end of 2018, the company's intimate customer relationships unveiled the struggle small businesses faced when expanding beyond one or two marketing channels. In response, Tailwind embarked on a transformative journey in late 2019 to create a multi-channel marketing system that's accessible and manageable for small businesses. They introduced Tailwind Create to generate customizable, brand-aligned images swiftly, an email marketing service to craft templates and campaigns, and integrated Replier.ai technology for drafting marketing copy. With over 1 million brands, small businesses, sellers, and creators served worldwide, Tailwind's product stands out as a comprehensive, easy-to-use marketing system designed to empower small businesses to expand their reach across multiple channels efficiently without losing focus on daily operational tasks. Up next, we're diving into the advancements in AI-driven automation. Twin Labs, a Paris-based startup, is on a mission to revolutionize the automation of mundane tasks, utilizing the cutting-edge capabilities of large language models, LLMs, with a twist. Co-founders Hugo Mercier and Joao Justi aim to create a unique product that can handle repetitive tasks like employee onboarding, inventory restocking, and financial report aggregation in a more reliable and efficient manner than traditional methods. What sets Twin Labs apart is its use of multimodal models equipped with vision capabilities, specifically GPT-4V. This approach allows the AI to understand and interact with software interfaces in a more human-like manner, recognizing features behind buttons and executing tasks without the need for API integrations or complex multi-step workflows. Their innovation lies in the AI's ability to load web pages, click buttons, and enter text, much like how a person would navigate a browser. The system is trained using screen recordings and natural language descriptions to ensure precision in task completion. Although still in development, Twin Labs' plan is to roll out a product with a library of pre-trained tasks and eventually open the platform for users to customize their automation needs. By moving beyond chatbot interfaces, Twin Labs is crafting an AI tool that tackles the tedious aspects of workplace tasks, potentially transforming productivity in businesses by automating the nitty-gritty of daily operations. And now pivot our discussion towards Learn AI. In today's AI learning episode, we delve into the fascinating journey of natural language processing, NLP, from the era of recurrent neural networks, RNNs, and long short-term memory, LSTM networks, to the revolutionary transformer models. Our story begins in the realm of sequence modeling, where for years RNNs and LSTMs reigned supreme. These neural networks were brilliant at handling sequential data, like text or speech, where the sequence of words or sounds is crucial for understanding. RNNs in particular had this unique ability to remember information from previous inputs, a bit like keeping a running tally of what's been said. However, they were not without their flaws. One significant issue was the vanishing gradient problem, which made it hard for them to remember long sequences. Enter the LSTM, a special kind of RNN designed to overcome this exact challenge. With its clever use of gates and memory cells, LSTMs could hold onto information over longer sequences, making them much more effective in applications like machine translation or text summarization. These RNN and LSTM models often used a sequence-to-sequence framework, particularly in NLP tasks. This setup involved an encoder to process the input and a decoder to generate the output. Think of it like translating a sentence from one language to another. The encoder digests the sentence in the source language, and then the decoder spits it out in the target language. However, this approach had its limitations, especially when dealing with very long inputs. This was where the groundbreaking transformer model, introduced in 2017, changed the game. Unlike RNNs, transformers ditched the sequential processing and embraced something called self-attention. This allowed them to weigh the importance of different parts of the input, making them incredibly efficient at capturing relationships in the data, no matter how far apart elements were. Two particularly influential versions of transformer models in NLP are BERT and GPT. They demonstrated the power of large-scale pre-training and transfer learning, pushing the boundaries of language understanding and generation. So, what sets transformers apart from RNNs? Firstly, their architecture. RNNs process data one element at a time and rely on their internal hidden state, making them sequential in nature. Transformers, on the other hand, are non-sequential and use parallel processing, thanks to their self-attention mechanisms. Another key difference lies in how they handle sequence lengths. RNNs can struggle with very long sequences due to the vanishing or exploding gradient issue, while transformers manage both short and long sequences efficiently. When it comes to dependency modeling, RNNs are great for capturing short-term relationships, but transformers excel at modeling dependencies regardless of their position in the sequence. This makes transformers particularly suitable for tasks involving long-range dependencies. In terms of size, RNNs are generally smaller and more compact, while transformers tend to be larger due to their more complex architecture. This size difference also affects their training and parallelization. RNNs are typically trained sequentially, which can be slower, whereas transformers benefit from parallel processing, speeding up training significantly. However, this doesn't mean RNNs are obsolete. They still have their place, especially in tasks where temporal relationships are key. But in many cases, transformers offer a more efficient and effective alternative. To sum up, the evolution from RNNs to transformers in NLP reflects a significant shift in how we approach sequence-based tasks. While RNNs and LSTMs paved the way, transformers have opened up new possibilities, balancing efficiency, accuracy, and interpretability. It's a thrilling time in the world of NLP, and we can't wait to see where this journey takes us next. Thank you for tuning in to today's podcast. We hope you enjoyed this exploration into the evolution of NLP models and gained some insights into the exciting world of RNNs, LSTMs, and transformers. Join us next time as we continue to unravel the mysteries and advancements in the field of artificial intelligence. Thanks for tuning in to today's episode of Innovation Pulse. If you enjoyed our insights and are eager to learn more, the Enlight Me app is just a tap away. Expand your knowledge with personalized content on over 20 diverse topics, from crypto to health and beyond, all curated to fit your interests. Download the Enlight Me app now at the Apple Store or Google Play, or visit the enlightme.ai website. Stay curious, stay enlightened.